Can we do a warm-up kind of revision session now for 5 minutes quickly? At the end of last week's lecture on Thursday, we had our GDP as measured by the by the expenditure approach equation. Okay, so in other words, we're looking at expenditure and we're looking at equilibrium between expenditure and output. So it's GDP as measured by the expenditure approach. We had an equation for consumption, which involved taxes. We had imports being an induced variable. In other words, it varies with Y. C is also an induced variable, varying with Y. And what I left you with at the end of last week was basically to take that information and to rearrange all those variables to get an equation that solved for Y if any one of the exogenous, or another word for exogenous is autonomous, if any one of the autonomous variables changed. So give an equation that gives you the change in Y if there is a change in any of the autonomous variables, and what that equation gives you is a multiplier. So it was basically deriving the multiplier in a sense. What I'd like you to do is just spend 5 minutes, depending on how long it takes you guys, just to redo that exercise quickly. So we want to rearrange this equation to show a change in Y if there's a change in any one of the autonomous components of expenditure. In other words, derive the multiplier, given that information. If you've got any questions, do raise your hands. What I discovered last week was that there was a lot of you sitting there without any idea what to do, but for some reason, no ability to vocalize or otherwise express this lack of capability. So what I'm saying is do it, and if you don't know what you're doing, please do raise your hand and I will come and assist you. Otherwise, take 5 minutes. So then just as a brief recap, we've got our expenditure equation, and we know that certain components of aggregate expenditure are induced components. In other words, they vary as Y varies. Then the problem that we have with the current setup is if, for example, we change one of the autonomous components, if we increase G, for example, what an increase in G will do is increase Y. It will increase our output. However, that increase in output will generate an increase in income, right? Which will generate an increase in consumption. That increase in consumption will generate a further increase in Y. That further increase in Y will generate a further increase in consumption, which generates a further increase in Y, and so on. So if we want to know how any autonomous component of this equation is going to change Y, what we need to do is rearrange our equations so that we don't have Y on both the left-hand side of the equation as well as on the right-hand side through consumption as well as through imports. So if we rewrite our equation, Y equals C, and here's our equation for C. C equals A plus B times Y minus, we said autonomous taxes as well as a tax rate. Okay. Plus investment, which is an exogenous variable, also referred to as an autonomous variable. I plus G plus X, all of those are autonomous, minus our induced imports. We've therefore got Y in a number of different equations. We want to bring Y all to the same side on the left-hand side because that's what we want to solve for, Y. So Y minus BY minus becomes plus BTY, sorry, Y, okay, BY, BTY, and then plus MY. This is baby M. Okay, and what does that equal to? A plus, let's do this. A minus B autonomous taxes plus I plus G plus X. Y is our common factor here, so Y times 1 minus B plus BT plus M equal to, now I'm just going to call all of this, these are all autonomous components, I'm just going to call them capital A, so it's equal to capital A, right, which means Y is equal to 1 over 1 minus B plus BT plus M times capital A being any one of those autonomous components. So if there's a change in any of those components of A, in other words, if there's some change in A, right, well, we know from basic calculus that change in Y over change in any of the exogenous variables is going to just be equal to the multiplier or coefficient, shall we say, in front of that autonomous variable. So this is what we call the multiplier. It's the coefficient on our autonomous components of the equation, which means obviously that change in Y is simply equal to 1 over 1 minus B plus BT plus M times change in A. Okay, so that was a quick recap of what we spent a bit of time doing at the end of last week. Last week, similar scenario, and we derived the same equation. Okay? Same equation. Any questions on that? Not, sorry? Oh yeah, anytime. Yeah. Autonomous components, also meaning exogenous components. In other words, these are components that do not change with a change in Y. Right? Remember, an induced variable, C is an induced variable. If Y changes, C changes. Right? Those are referred to as induced variables. Okay? If it's not an induced variable, then it's just an autonomous variable. If you are used to maths terminology, then the terms we would use would be exogenous variable versus endogenous variable. C as an induced variable is an endogenous variable. G, as an example, as an autonomous variable is also an exogenous variable, meaning it doesn't change with Y. Okay? Any change in G comes from outside of the system. Any other questions? No? Okay. Okay, let's just do a brief overview of where we are and what we've done, if you recall. So we've done basically, so we've done chapters 21 to 24, plus we are now finishing off chapter 27. Chapter 21 was basically just an introduction. It was all about measuring what we're interested in macroeconomics, which is GDP. Then chapter 22 was about measuring other stuff that we're interested in, like inflation, as well as unemployment. In terms of measuring GDP in chapter 21, we saw that there were two ways that we could measure it. There was an income approach and an expenditure approach. In chapter 23, we were looking at GDP in terms of was it the expenditure approach that we looked? Was that chapter 23? It was growth, whatever. GDP growth, and did we focus on the expenditure approach in that growth discussion or not really? There wasn't really a discussion on what approach we used. So okay, that's fine. So in chapter 23, when we looked at GDP growth, we were looking at obviously how this thing changes over time. you can measure that change either in terms of the expenditure approach or the income approach. But what we've seen in chapter 27 is that when we're looking at GDP, what we're doing is focusing on, so chapter 27 was really a focus on GDP in terms of the expenditure approach. So what we're going to see whenever we talk from now on, if we're talking about GDP growth or change in GDP over time or measuring GDP generally, our focus is on the expenditure approach. And that's what chapter 27 was looking at. Chapter 27 was saying, right, we know we can measure output, right, output, in terms of an expenditure approach, but we know that we can also measure it in terms of an income approach, and essentially we have the circular flow which says that income must equal expenditure. Okay? And what we saw in chapter 27 was why we will always have equilibrium. So chapter 7, Y being output, and then we have this thing, aggregate expenditure, okay, which is just our measurement of expenditure in the economy as it is planned. So usually when we talk about aggregate expenditure, we're implicitly meaning planned expenditure. So if our aggregate expenditure is planned, what we saw in chapter 27 was why we will always have a movement towards a position where output equals aggregate expenditure, which is why we end up with the circular flow system, because expenditure becomes income, income becomes expenditure, and the two of them tend to be equal. So that's what we've seen in chapter 27. In between all of this, we also looked at chapter 24. In chapter 24, we looked at basically, it was a focus on loanable funds market. And the loanable funds market was another way of saying that savings always equals investment, okay? Which is another way of saying that if we look at output as measured by the expenditure approach, C plus I plus G plus X minus M, and we look at output as measured in terms of the income approach, which is output must equal C plus T plus S. If we put these two equations together, then we notice that C plus T plus S must equal C plus I plus G plus X minus M. Obviously, C on both sides cancels. You can rearrange this equation and write savings is equal to investment plus plus, okay, or I can write this alternatively as investment is equal to savings by private households plus savings by government plus any savings from the rest of the world that we are borrowing. If we have a closed economy, then we don't worry about this. If we have a private economy, so there's no government, then we don't worry about this. Then savings must equal investment. If we have an open economy and our economy is public, in other words, we have government, then investment comes from either private savings or government savings or borrowings from the rest of the world. Either way, these are all different types of savings and they must equal investment. So our loanable funds market was basically just another way of saying that income must equal expenditure. Circular flow diagram. Okay. Any questions on that? Does that make sense to you? Does that follow what you think we've done so far? Okay. Anything new there? Anything that you're not comfortable with? Anything you want to raise a question about? No? Alrighty. Okay, let's continue then with chapter 27. As I say, we should be able to finish it off relatively quickly, and then we can do some revision in the second half of the lecture in preparation for tomorrow, when we will do questions which come from you guys. So chapter 27, we're talking about the Keynesian model. What is the Keynesian model? It's a short run model of expenditure. Okay? Key to the short run in macroeconomics is that we treat prices as fixed. So if prices are fixed, how do we achieve equilibrium, in other words, between output as an income source and outcome as an expenditure source? So we produce some amount of output, and we're going to spend some amount on that output. And if we're in equilibrium, then the amount that we produce and the amount that we're buying essentially must be the same. If there is a disconnect between the amount that we're producing and the amount that we're buying, then the economy needs to adjust somehow. We've seen in microeconomics that one way in which things can adjust is through price changes. For now, we're treating prices as fixed and saying, well, if prices are fixed, is there some way in which the economy can adjust itself? This model is a way of saying, yes, there is. So the key to this model is a discussion about planned expenditure. So remember that when we're talking about planned expenditure, the components of expenditure are C, I, G, X, and M. And what we're going to discuss when we talk about planned expenditure is aggregate expenditure. We call it AE. And there's a relationship between aggregate expenditure and output. We've seen in our introductory chapters that what we focus on is the equilibrium condition, where the amount that we produce, output, is in fact equal to what we spend. Okay? What we see in this chapter is that this equation doesn't always hold. If it doesn't hold, how does the economy realign itself if there is any kind of disequilibrium? Why was this an interesting question? Well, we've got the business cycle. We know that the economy doesn't just grow in a straight line. Sometimes it produces in periods of expansion, and sometimes it produces in periods of contraction, where the amount that gets produced is just consistently lower and lower and lower. What prompts the economy to produce less and less and less over time? What prompts the economy to produce more and more over time? These are the sorts of questions that we're discussing. So if you're following through your slides, there's this rather cryptic statement which says there's a two-way link between aggregate expenditure and real GDP. An increase in real GDP increases aggregate expenditure, and an increase in aggregate expenditure increases GDP. In itself, that doesn't tell you much, but obviously given our discussion over the last 2 days, it should be clear that what that statement is referring to is this relationship, where some of our variables, our expenditure variables, are in fact induced expenditure variables, which means that they vary as Y varies. In other words, an increase in real GDP can increase aggregate expenditure, and an increase in aggregate expenditure can increase real GDP. If we're considering the equilibrium condition, in other words, Y output equal to consumption, equal to expenditure, and we consider the aggregate expenditure equation, which looks very similar, the question is, what's the difference between these two equations? Well, the difference is that in our equilibrium condition, the investment that we're referring to is actual investment, whereas if we're just talking about the aggregate expenditure equation, the investment that we're referring to is what we would call planned investment. Okay? So these two equations are in fact equal if actual investment is equal to planned investment. We're going to focus on disposable income for the moment. Disposable income just means income minus taxes. So we started with the idea of a consumption function, and a consumption function meaning that consumption varies with income, which means that it is an induced variable. Essentially, we decided that, whatever. We have a theory that consumption is dependent on income. So we write consumption is equal to A plus B times income. B is the proportion of our income that we consume, the proportion of a change in income that we consume. A is just some amount of consumption that we will be embarking upon, regardless of whether we have any income or not. And we discussed that in great detail. If we now plot this consumption function, C equals Y plus C equals B plus, C equals A plus BY, and for now we're going to let Y equal YD. In other words, the component of consumption that we're interested in is disposable, so after taxes. Then we can plot our disposable income, which is our Y variable, disposable income against consumption. Okay. Sorry, I said Y variable, X variable. Y is our X variable, which sounds confusing. C is our Y variable. In other words, it's on our Y axis. So plotting C against disposable income, consumption against disposable income, we have an upward sloping linear function. It's got a positive intercept given by A. It's got a positive slope given by B. That slope is less than 1. The savings function is, in a sense, the inverse of that consumption function. If we then combine our consumption function with our other autonomous components of aggregate expenditure, we end up with an aggregate expenditure function, which is upward sloping. It has some positive intercept. It has a positive slope. And that slope is determined by the slope of our consumption function. If there are any other induced components of aggregate expenditure, then the slope of the aggregate expenditure function will also be dependent on those other induced variables. In other words, in fact, let's look at this. When we looked at this last week, we did a basic multiplier equation. We saw that if we treated taxes as equal to 0 and imports as equal to 0, so that consumption is the only induced component of expenditure, then our multiplier depends only on the slope of the consumption function. In other words, consumption is the only induced variable, so it's the only variable that enters into the multiplier. When we expanded our function to include autonomous taxes as well, not autonomous, when we included it to include induced taxes as well as induced imports, so our equation became Y equals A plus B times Y minus autonomous taxes minus induced taxes plus I plus G plus X minus induced imports. Then we see that our multiplier includes not only induced consumption components, but also induced taxes and induced imports. Okay? This is the slope of our aggregate expenditure function. Okay? Sorry, that's not the slope. This is the multiplier. The slope is just the value of the various autonomous components. Okay. In other words, as Y changes, right? As Y changes, our expenditure will change by a function that's by an amount that's a function of both M and T and B. Okay? So when we look at this diagram from our textbook, We've got an aggregate expenditure function where the slope only depends on B. And then we've got an aggregate expenditure function where the slope depends on both B and M. So the slope changes once we include M. Given our aggregate expenditure function, we note that there is only one point at which the aggregate expenditure function intersects with our 45-degree line. What is important about the 45-degree line is it gives us all the locations or all the locuses or all the loci of equilibrium between real GDP and aggregate expenditure. So anywhere on the 45-degree line, real GDP and aggregate expenditure are equal. So anywhere that our aggregate expenditure curve intersects the 45-degree line will be the point where aggregate expenditure, as measured by the aggregate expenditure curve, is actually equal to real GDP. So aggregate expenditure is only equal to real GDP at one point, at the point of intersection. So what happens if we're at some level of aggregate expenditure, say point A, point B, point C, or point F? If we're at one of those points of aggregate expenditure, we know that the amount of aggregate expenditure is not equal to the amount of output. In other words, the amount of stuff that we're buying is not equal to the amount of stuff that we're producing. At point A, the amount of expenditure exceeds the level of output. At point F, the level of expenditure is less than, so it's approximately 14, is less than the amount of output, which is approximately 15. What happens, therefore, if we're at point A or point B, point C, point F, any of those points? What we saw last week was that there would be an unplanned change in inventories. In other words, inventories would either be increasing in a way that was unplanned, or they would be decreasing in a way that was unplanned. If inventories were increasing in an unplanned way, that's a signal to firms to adjust their production. If we are consuming less than we are producing, firms have an unplanned increase in inventory. So what do? They cut back on production. As they cut back on production, output falls, so we move to the left. As output falls, aggregate expenditure falls, and we move to the left along our aggregate expenditure curve. And we continue in that same pattern until we reach this equilibrium intersection point, at which point there is no unplanned change in inventories. Everything that we are producing and planning to sell, we are able to sell. Alternatively, if we are at, for example, point A, what is happening? We are spending more than what we are producing. Firms are having an unplanned decrease in inventories. In other words, their inventories are decreasing faster than what they expected. What do they do in response? They start producing more. As they produce more, output increases. An increase in output means a movement upwards to the right along the aggregate expenditure curve. And we continue to move rightwards up along the aggregate expenditure curve, producing more and more, until we get to the point of equilibrium, the intersection. At the intersection, once again, firms no longer have any unplanned changes in inventories. Everything they produce is what they sell. Any questions? Anything that you were uncertain about in that discussion or in that revision? Are you all 100% comfortable with what we're speaking about? No issues? Okay? So we saw this both as a diagram and we saw what it looks like in a table. We then described how the multiplier is represented in this diagram. What happens, and let me just draw it because that'll be easier to describe as I draw. If we have our aggregate expenditure model. So we've got output versus aggregate expenditure. We have a 45-degree line. The 45-degree line gives us all the different points of equilibrium between aggregate expenditure and output. And we have an actual, aggregate expenditure function. So this is aggregate expenditure. We have some point of equilibrium. And our aggregate expenditure is equal to C plus I plus G plus X minus M. And what I'm going to do is I'm going to change government spending. So I'm going to call this G0. Okay? Now what I'm going to do is say that government spending changes. G0 becomes G1. Okay? And in fact, it was an increase in government spending. So G1 is greater than G0. There's an increase in government spending. If I were to, so I'm going to call this AE0, corresponding to government spending 0. If I were to plot AE1, bearing in mind that AE1 is now going to contain G1, right? Where would I plot AE1 relative to AE0? Above or below? If I was going to plot AE1, does it lie above AE0 or below AE0? Does silence mean absolutely no idea? Above? I'm going to increase one of the components of aggregate expenditure. If I increase one of the components, what am I doing? I'm increasing the intercept value. If I'm increasing the intercept value, what must I do? Plot AE1 above AE0. Okay? Initially, given AE0, I had some equilibrium level of output, Y0, and I had some equilibrium level of expenditure, AE0. If I've increased expenditure to AE1, okay, if I've increased to AE1, so if I continue my discussion, my little notes here, AE1, are you happy that AE1 is greater than Y0? Here's Y0, Y0 is equal to AE0. I've now got AE1. I've increased government spending by some amount. I'm now at AE1. Are you happy that AE1 is greater than Y0? If you want, I can add one more step to this. Are you happy that AE1 is greater than AE0? And AE0 is equal to Y0. Therefore, AE1 is greater than Y0. Okay? Now consider this point, and let's call it point A. Point A. Okay? Going back to our notes. Are you happy that point A in this diagram here corresponds to, for example, point A in this diagram? Point A in this diagram, point A in this diagram. Point A lies somewhere on the aggregate expenditure curve above the 45-degree line. Point A is on an aggregate expenditure curve somewhere above the 45-degree line. You happy with that idea? Following me? Okay. What happens when we're at point A? What happens to firms' inventories at point A? Okay, inventories decrease, and it's an unplanned decrease. Yeah? Sorry, I wasn't sure who said that. So. Okay, you happy that was an unplanned decrease in inventories? So how do firms respond to an unplanned decrease in inventories? What do they do? Produce more? What can I do to encourage some engagement here? Because otherwise I'm just talking to myself. Yeah? Absolutely. Price changes is one strategy. At the moment we're talking about the short run where prices are fixed though. Okay? Imagine we're in a perfectly competitive environment, so no firm has any control over prices. If everyone's producing at the same price and you try and raise your price, what happens? Everyone just goes to someone else to buy, right? So you've got no control over prices. You can't just change prices yourself. Okay? So we assume that prices are fixed for now. That's our short run model. That's the key to this model, right? Keynesian model, prices are assumed fixed at the moment. So if prices are fixed and firms are selling more they're selling more output than what they anticipated, what do? Okay, so they start producing more. As firms start producing more, output starts increasing. As output starts increasing, what do? We start moving to the right, up to the right along our aggregate expenditure curve, and we move rightwards until we reach our new point of equilibrium. And here we're going to have output Y1, and I'm just going to call it Y1 equilibrium, which corresponds to, that looks horrible, a E1 equilibrium, which I'm just using to distinguish from this point here, a E1. Okay? A new equilibrium point. At our new equilibrium point, the amount of output produced is equal to the amount of expenditure. There is no unplanned change in inventory. There is no signal to firms to produce more. There is no signal to firms to produce less. So they just continue producing whatever they are producing and selling whatever they are producing. We're in equilibrium. Everyone's happy. Okay? What has happened in this process? Let's look at it as an equation. We had some level of expenditure, AE0, equal to Y0, equal to C plus I plus G0 plus X minus M. Okay. Let's just let this equal 0, let this equal 0, and then let this equal 0 just to make our lives easier. And we let C equal A plus B Y. So we just let taxes equal 0 as well. So in other words, taxes equal to 0. Again, just to make our lives easy. There's no reason for us to believe that those are 0. Could be any constant. So rather than making them 0, I could just make them a constant, say put a bar over them to mean that they're constant. It would mean the same thing for our discussion. So we had initially equilibrium, AE0 equal to Y0 equal to C, which is A plus BY. Y in this instance would obviously be 0 because we're at equilibrium, plus G0. Okay? Then we had a new level of aggregate expenditure, which I called AE1. AE1, which was equal to A plus B Y0. We're still producing output Y0 plus G1. And then the rest of that stuff we're just making zeros. Okay? And what we know at this point is that this is greater than Y0. Therefore, we are not in equilibrium. Okay? That is what we know about our point A. So this was point A. We had some level of aggregate expenditure associated with G1, which was greater than the level of output Y0. So what happened? Well, For equilibrium, what do we know about equilibrium? At equilibrium, we need y equal to 1 over 1 minus b times the autonomous components. We've only got two autonomous components, a and g. Okay. Our initial equilibrium, so let's just write here, initial equilibrium was y0 equal to 1 over 1 minus b times a plus g0. Okay. Our new equilibrium will be given by y1 equal to, let me just, sorry, before I write that, let's write a new equilibrium. y1 is equal to 1 over 1 minus b times a plus g1. Okay? But given our equation, we know the following. Adjustments will occur. Change in y is equal to 1 over 1 minus b times change in g. Okay? In other words, change in g. Okay? So, if our change in g is g1 minus g0, okay? Where is g1 minus g0 on our graph? Here is the distance. Well, let's do this. This distance is g1 minus g0. In other words, when government spending changed, what happened to our aggregate expenditure curve? It shifted upwards, right? g1 minus g0. Okay. What will the change in y be? The change in y is not the same as g1 minus g0. The change in y is g1 minus g0 multiplied by our multiplier. Okay? In other words, the change in y, where is the change in y? Let's do that in a different color as well. The change in y here is y1 minus y0, right? This is the change in y. Let's write it in here. So change in y, y1 minus y0 is equal to the change in g multiplied by our multiplier. In other words, this distance here, change in y, is much greater than this distance here, change in g. Why is this distance longer than this distance here? Because of the multiplier effect. Remember, if this is a 45-degree line, this increase in g, this distance here, is equal to this distance here. This is a triangle. Okay? Triangle, what do you call it? An isosceles triangle. So this distance here is g1 minus g0. This additional distance here is due to the multiplier. This is the multiplier effect. Okay? In other words, we take this change and we multiply it by some amount to give us the full change. Now, why is it doing that? Because remember, in my equation here, when my government spending increases, right, what happens? My aggregate expenditure is greater than my output, so my output, that induces firms to increase output. That increase in output leads to an increase in consumption. That increase in consumption leads to a further increase in output. Right? In other words, in our equation, in our expenditure approach equation, C is increasing as Y increases. So this increase in G causes an increase in Y. This increase in Y causes an increase in C. That increase in C causes additional increases in Y. Okay? So we can kind of break this down, I guess. I'm just trying to find a color that's going to work. This here really is the change in... So this is the change in Y that equals the change in G. Okay? And then this component over here is the change in Y that comes from change in C. There's a further induced increase in output. And that's the multiplier effect. Maybe I should... let's make all of that blue. Okay, should we take a break?